In these problems, we are using Pythagorean identities to simplify trig expressions. And we want to get a big complicated thing like this, cosine squared x times sine x plus sine cubed x, down to either a single trig function or maybe even down to just a number. We're going to use these Pythagorean identities we have over here on the side. This one, definitely keep your eye out for. Anytime you see sine squared plus cosine squared, you can replace it just with the number 1, which is pretty cool. These others, tan squared plus 1 equals the secant squared, and cotangent squared plus 1 equals the cosecant squared. Those will pop up from time to time as well. So let's see what we can see in this one. So because I've done a few of these before, what pops out at me right away is that hidden in here is a cosine squared plus sine squared. If I factor out a sine from each of those two terms. So I'm going to do that. I'm going to factor out a sine x, and what that leaves is cosine squared x plus sine squared x. Now, it doesn't matter what order those are in. It's cosine squared x plus sine squared x is the same as sine squared x plus cosine squared x. So this whole chunk of stuff equals 1. So this is just the sine of x times 1, which is just the sine of x. And that's it. We got that down to a single trig function. Let's try another one. Okay, so here, well, I don't see a sine squared plus cosine squared right off the top of my head. I do see an identity though. In parentheses, we have this 1 plus tangent squared of x, and that can be replaced with the secant squared of x. So let's try that. So sine squared x times secant squared x. Now the secant is 1 over the cosine, so this is sine squared x times 1 over cosine squared x. That's just sine squared x over cosine squared x. That's the sine over the cosine is the tangent. So we could write this as tangent squared x. And now we've got that down to a single trig function. So that is a little work with using the Pythagorean identities to simplify trig expressions.